Welcome to Science Goes to the Movies, a look at the stories of science and how they change our culture. I'm Lisa Beth Kovetz. The Aeronauts is a semi-biographical film starring Eddie Redmayne and Felicity Jones, directed by Tom Harper, based on the book Falling Upwards by Richard Holmes. It takes place in the 1860s, and in it, the established members of a scientific society deride a semi-fictional version of a real scientist, James Glaisher, saying the weather is simply far too chaotic to ever be predicted at all. Fast forward to this morning when, before walking my dog, I consulted my smartphone to determine optimal weather conditions to the hour, because my dog is a little weird about the rain. Joining us today to talk about the weather is CUNY's own Dr. James Booth, Professor of Earth and Atmospheric Science at City College of New York. Jimmy, welcome to the show.
Hi, thanks. I'm happy to be here.
The Aeronauts is based on the first balloon ascension to 37,000 feet, an event which actually took place in real life in the 1860s. An enormous amount of weather science was packed into that single hour of floating upwards, and it seems, from the movie, that the most significant discovery was that the air around and above us has both layers and patterns. So, Jimmy, what the heck are layers and patterns of air?
It's a great question. And one thing I think we've all heard of is the jet stream. And that is the air that's blowing much higher up than the surface, around 10 kilometers up. And the air at the jet stream is moving much faster than the air at the surface. And if we're thinking about weather forecasting, then when we go up to that sort of height, the behavior that's happening up there, especially to the west of us, gives us an idea of what's coming. As you move up in the atmosphere, it gets colder, and it gets colder pretty quickly, so that by the time you get up to about 10 kilometers, it's around negative 50 Celsius, so very cold. And the interesting thing, what I find to be really interesting is after that, as you go even higher, the temperatures start to get warmer. And so in atmospheric sciences, we actually separate the layers of the atmosphere into the troposphere, which is about from the surface to 10 kilometers. And that's where all of the weather occurs. That's where all the clouds are. And then above that, from about 10 kilometers to 50 kilometers, is called the stratosphere. And in the stratosphere, the air is actually warming as you go up to higher heights.
When you say warm, we're not talking tropical 80, put on your bikini.
Oh yeah, no, just zero Celsius is like the maximum on average that it gets up there. So still cold, but just much warmer than it is at the top of the troposphere. So it's like cold, chilly, really, really cold, and then cool and cold as you go up past that. The airplanes that go across the US, New York to LA, they fly right about at that height of the temperature minimum.
How did it get the name jet stream?
In the beginning, when people were thinking about the air and how fast it was moving, they're thinking, wow, it's up there moving kind of as fast as jets. And they give it a name for that reason. In terms of like which came first, us flying near the jet stream versus the name, we actually try and always fly above the jet stream, just because there's less turbulence there. Yeah, but not much higher than that, because in the stratosphere, it gets much more difficult because there's a lot less air mass. And so the air that's being pulled into the airplane is a lot harder to process to get it back to a pressure that we can actually breathe.
At one point in the film, Redmayne's character asks, is it not our responsibility as scientists to find order in chaos? But is the weather actually chaotic, or is it just made up of so many variables, so many layers and patterns that it seems that way?
Yeah, I'd say it's chaotic. But I would say both are true. So if we go really technical with a mathematical definition of chaos, it is a system in which very small changes in the initial conditions can lead to very drastic changes later on in the time evolution of that system.
Yeah, most people think of the butterfly effect as a time travel thing, but really it's a meteorological thing.
Oh yeah, nice. Your other point is well taken too, though, that there are so many variables that are important for how the weather behaves. that when we go to make a prediction of the weather, we have to really incorporate a ton of that information in. And in the kind of like fun or interesting parlance of our day, we are working with systems of big data.
Jimmy, in the movie, Eddie Redmayne's character is measuring height with some kind of a pressure gauge, and they don't actually call it by name in the movie, but the real Glaisher and his actual co-pilot, Henry Tracy Cowell, had a barometer. And barometer is like this word that I use without totally understanding the actual underlying scientific instrument. So what the heck am I talking about when I say that something is a barometer?
Yeah, it really has kind of become a colloquialism now, and probably has a bit of a different meaning than it originally was. But for atmospheric science, barometer measures the pressure. The idea is that the atmosphere, although we don't see it, is made up of stuff. So the gas molecules weigh. The amount of pressure weighing down at any given time depends on the weather patterns. And so with a barometer, we can measure how the pressure is changing with time, and then we can link that back to weather patterns.
The science in the movie, The Aeronauts, was all about discovering changes that occur as we ascend. But your group at City College focuses on the measurement of a different spatial region called the mid-latitude. So Jimmy, tell me all about the math porn that is your paper titled Mid-Latitude Storms in the Moisture World.
Right. Yeah, in fact, I'm embarrassed to say that I wish I had more math in it. I was trained as a mathematician before I became an atmospheric scientist. And actually my first year in my graduate program in atmospheric science, they started writing these things on the board, and I was shocked at how atmospheric scientists treat math. It's a lot looser, we'll say. But yeah, once you get into these fields, it is the case that there's a lot of technical details that go into quantifying how things work. And in that paper, what we were interested in understanding was theoretically, or in an idealized setting, how do the mid-latitude storms, the kind that affects New York City the most often, how do those storms change in their behavior if the atmosphere has more water vapor in it? The reason we wanted to study that is because with anthropogenic climate change, we have definitive proof that for regions like New York, we're going to have more water vapor in the air. And so we want to know, will this affect how the storms behave, both in terms of their winds and their precipitation, and also in terms of how fast they intensify? And so that work used a numerical model, and I had some really good collaborators on that project. And we as a team kind of came up with the plan for how we would change the settings in the numerical model to test what happens to the storms. And we find that the storms get stronger in terms of their winds, they rain more, and they develop faster. Now, we were doing idealized tests. We were not accounting for all of the variability that we see in the atmosphere. And so there's other things that could change that will also affect the storms. So this take home that I've just said, I wouldn't say is a guarantee that all storms in a future climate, because of this water vapor effect, are going to be stronger in their winds. Instead, it's saying that if everything else in the climate didn't change and we just had more moisture, then we would definitely see those effects.
Even so, fix your roof, buy that pump.
Well, yeah, and on that, in that respect, that's right. And with everything that's changing, it's still going to be the case we're going to have more water vapor, leading to more precipitation. So wetter storms are, without a doubt, more likely.
Yay.
Yeah, but I will say, like, year to year, the variability that we have from one winter to the next has helped us be pretty well prepared, so that over the next 40 years, humans, I think, will be able to somewhat adapt. We're going to get more of these extreme events, though, like we had with the remnants of Hurricane Ida. So the probability of an event like that was calculated after it happened. And in some places, they said a rain event like that is like a 1 in 1,000 year event. And so we would say, oh, whew, we probably won't have another one for 1,000 years, or the likelihood is really small. But that's not the case, because we're changing the climate in such a way where things like that, their probability is going to increase. So we're going to expect a higher probability of that exact type of event 20 years from now as compared to right now.
But do you think because the Northeast is accustomed to variability that we are better set up to deal with this variability?
I would say we have a better chance to adapt to it. I wouldn't say it's going to be good the way things are changing, and especially summer changes are not going to be good. But when we teach about weather and climate, I like to say weather is what you're wearing today, and then climate is what you have in your closet. And then we think about what kind of outfits do we have in our closet in New York City, we're ready for the 4 seasons, right? So we have a broad range of weather types that we're getting used to. For people who live in the tropics, it's more difficult, right? The climate over the course of a year is not as variable. And therefore, not just people, but the plants that are there, the animals that are there, are not as used to wide-ranging changes. And so small changes in the overall climate have a bigger impact, or potential to have a bigger impact for them in terms of things like crop yield and habitability for the animals. All that being said, for New York City summer, it's going to get worse. And, there's no smaller outfits than what we already wear, right? we're going to be dealing with some kind of miserable temperatures sometimes as things get warmer.
Yay. Yay. Blizzards don't get names like hurricanes do, but in 2017, winter storms bombed the northeastern region of the United States. And some of us learned some very interesting new words like cyclogenesis and bombogenesis. What are those things?
So cyclogenesis is a term that we use to talk about the formation of the storm and then its growth from a small disturbance to a large disturbance. And the reason it's cyclogenesis is because the storms themselves have a rotation component to it. We actually want to imagine the size of the state of Texas of air rotating counterclockwise. And that is what we call cyclonic rotation. And the birth of it would be the genesis. So cyclogenesis is the birth of the cyclone. Bombogenesis is the birth of a specific type of cyclone, one that grows from a small disturbance to a really intense wind disturbance in a short amount of time. So it's as if a bomb has gone off in the atmosphere, because you go from conditions that are kind of calm to really dramatically intense. If you're ever watching the news, you'll see them talking about fronts, like a cold front is coming or a warm front is coming. The fronts are strong differences in temperature near the surface, and they're part of an extratropical cyclone. The naming of them is kind of cool too. In the 1910s, the field of meteorology was really starting to develop. And this was about the same time as World War I, where they're fighting along fronts. And so the term front for atmospheric science was kind of borrowed from the terminology used during World War I.
How expensive are these storms?
Yeah, they can be really costly. So there's actually an annual compilation of what are called billion-dollar disasters, where the organization called NOAA, which is an acronym, the National Oceanic and Atmospheric Administration, NOAA, compiles an estimate of the cost of these events. And they are extremely expensive, and they're becoming more expensive. And the reason they're becoming more expensive is partly because the natural hazards themselves are becoming more intense in some cases, but also the number of people and goods that are in harm's way has increased, right? And so in tornado science, one analogy that's been made is that the bullseye has just been made bigger, right? And so tornadoes have become more expensive, but a lot of it is just because we've developed in regions where the tornadoes are. And so they have an easier time hitting things. And similarly, we're doing a lot of development along the coast, right? And so in these regions that are prone to landfalling hurricanes, we just have more people and more things that can be destroyed. The
movie The Aeronauts took place in London, and London is famous for having both very specific weather and very specific climate. So what is the difference between climate and weather?
Yeah, so the difference is really timescales. Weather occurs on shorter timescales, or it's the study of the atmospheric phenomenon on shorter timescales, days to weeks, maybe multiple weeks. Climate is the study of weather accumulated over multiple timescales. And so climatology is actually the statistics of multiple years of weather. Another way to say it is climate is what we expect, weather is what we get.
Are there winners and losers in climate change?
In my view, there are losers and worse losers. I think all of us are going to have some little things where we say, wow, that's a silver lining. But overall, based on how I understand the evolution of humans, the evolution of the biosphere, timescale of anthropogenic climate change is too fast for any of that to adapt very well. And therefore, everywhere, there's going to be new stressors that we haven't thought of. A good example that's not nice is that in the Pacific Northwest, the climate is becoming more mild in winter, and that increases the growing season. So therefore, it could be kind of good for trees. But the milder winter also means that the pine beetles don't get killed off as badly in winter. And as such, they're killing more of the trees. So we're start out with just thinking, well, it's going to be warmer during winter, thank goodness. But the side effects of that on the biota end up oftentimes coming back and making things a little worse for us.
Because of the speed that the climate change is occurring on an evolutionary scale.
Yeah, it'll be hard to find winners.
And what about environmental injustice?
Unfortunately, climate change is exacerbating environmental justice problems. And so for me, it feels like we can solve both actually by putting more attention on the environmental justice side of things. And it's a really hard problem to tackle, but it's one that we can't ignore. And if we do ignore it, anthropogenic climate change is just going to make things much harder and worse.
The Aeronauts is a fun film about long ago men and women living in a comparatively steady climate, getting their foot in the door of the science of predicting the weather. And these days, it seems like the weather has gotten so chaotic that meteorology is a lot of probabilities with boundless variables, but probabilities is a hard concept to share outside of the math and scientific community. How do you explain all the maybes to the general public?
Great. Yeah, actually, that is a question that NSF, the National Science Foundation, is trying hard to answer right now. They're actually funding new projects that are exactly identifying this idea of how do we improve the communication of our uncertainties. I wish I had an easy answer. I would say that when it comes to risk and people's perception of risk, we're still learning a lot. I have a small interaction with a group in the psychology department where we're thinking about these things because part of it is like, how does everybody individually respond to imagery and then take action? Because if we want people to appreciate that the changes with anthropogenic climate change are going to be devastating, what is it we need to actually tell them about? What's their interest? If we want people to believe that Hurricane Ida is going to be dumping catastrophic amounts of rainfall and that they need to act, what are the right words we need to say to do that? I don't know. I do know we learned from Ida that the weather forecast knew about it, was correct, and it was communicated, and people still didn't act. And so it seems like it's part of the problem now is how do we take this as the last time it happens like that? How do we help really engage with communities to be very clear that when the forecast says it's this amount of rain, even if it's a 50% chance, you better act on it or else you're gambling on your life.
In real life, the British Association for the Advancement of Science chose James Glaisher, hired Henry Coxwell. They did not hire the very charming Amelia Wren because, like all women in the eyes of the circa 1860 British Association for the Advancement of Science, she did not actually exist. But for a modern audience, the aeronaut director Tom Harper had James Glaisher submitting to a literal dog and pony show to get his experiment funded. Jimmy, in modern day science, specifically climate science, are you subject to the whirlwind influences of money and showmanship?
Yeah, a little bit. It's unfortunate, but it's true. So a lot of our funding comes from the U.S. government, and in that case, what we're subject to is the changes in the whims of the administration. So the amount of funding for climate now is actually rebounding from where it was 2 years ago. Separate from that, there is a interest from private industry in climate science for different reasons. Sometimes for profit, other times to just try and help the environment. So how do you go about showing that you have a good idea? You first have to publish a paper, and the journal in which you publish your paper translates to viewership. And so in climate science, there has been a lot more interest in this topic, and then the amount of publications that's going on in magazines like Science and Nature has increased. And on one hand, that's really great because that it really is increasing the viewership of these ideas. But on the other hand, Science and Nature are publishing companies that have their own interests as well. And so these things have to be weighed up as decisions are made about publishing, and then that translates into decisions about how well advertised you are, which translates into decisions about how the funding agencies feel about your work. In an idealized world, any person would just come up with a great idea, and if it was a great idea, it would find a place to get funding. But in reality, your great idea is subject to a lot of different choices and decisions along the way.
How do you stay grounded as a scientist when there are so many debates and misinformation about the weather?
I would say I, on the one hand, turn to the math because the math has only one path towards solutions and whatnot. And then on the other hand, I'd say for me, the grounding in part comes from getting to talk to people like you, getting to talk to the students, and getting a neat kind of perspective on, oh, well, here's the things that we're most interested in, and we need to understand better. And that brings it back for me to being having an idea that, all right, so when I'm doing the communication of my science, this is what I need to prioritize.
But we're talking about the science of prediction and probabilities, and there are all kinds of forces trying to control the truth. So in light of these variables, do you have any suggestions for how a person, either just a lay person or a scientist or just somebody making their way through the world, can recognize what is reality? What is real?
I chuckle a little bit at that question because I just recently rewatched the movie Inception, where they're stuck in dreams and it's not clear which dream is reality. But in courses that I teach, we talk about finding out scientific truths and understanding how to query the internet best to look into these details. And it's nice that now with the internet, we have access to information like we never had before. But it also means that things get out there on the internet that aren't necessarily put through their paces. So I always tell the students, you want to look at multiple different websites for this information. Generally, you can find websites that are .gov websites that typically have less of a reason to be biased. in terms of weather and climate. They're there to report what's been observed. And then separate from that, especially in weather and climate, things rely on physics. And so if you're curious about something and you really want to understand it, you might have to take a step back and gain the fundamentals, and then move into the elements of the physics of the atmosphere. So, in the beginning, I mentioned details about pressure. And so the physical concept of pressure is actually a really interesting thing. We're talking about the force over a given area, and we can all write down an equation that actually relates pressure to just two things: force and area. And these type of less complicated math equations are all that's really needed to get from point A to point B for the general understanding of weather and the general understanding of climate. It would be ideal if there was a news channel that was completely abstracted from bias.
Jimmy, there's just never enough time, and we're out of it again. Thanks so much for talking to us.
Thank you. I enjoyed it. Thanks a lot.